Hi guys, in the last video we worked out what solving simultaneous linear equation literally means. In this video we are going to figure out how to do it. Well, there are various ways. We shall study the elimination method today. It literally means we manipulate the two simultaneous linear equations in a way that one of the two variables in the equations is eliminated. And as a result, we can easily work out the value of the remaining variable. So let's see an example. So here's the first equation, and we label it equation A. We label it so it's easier to refer to this equation later on. Likewise, the second equation, we label it equation B. Now we have to eliminate a variable, so just pick a variable of your choice. Say we pick the variable y. We want to eliminate y. Now, how do we do that? Remember, notice in equation A there are 3 y's, and in equation B there are 5 y's, and there's a negative sign as well. So what we can do is we can try to find a common multiple of both 3 and 5. So what could be the lowest common multiple or LCM of 3 and 5? Well, it turns out it is 15, because 3 times 5 is 15 and 5 times 3 is also 15. So if we want to eliminate the y's, we'll have to make the y's equal in both the equations. So to do that, we are going to multiply equation A by 5. So multiplying an equation means we multiply both sides of the equation by 5. So A turns into 10x plus 15y. So 5 is multiplied by the left side, so 2x became 10x and 3y became 15y. And similarly on the right side, the 13 also got multiplied by 5, so it became 65. So now we've got another equation, we label it C. For the equation B, we also have to multiply it by something. So because there are 5 y's there, we will multiply equation B with 3. I hope you agree with that. So once we do that, well, equation B, the left side of the equation B, becomes 21x minus 15y. And the right hand side becomes minus 3. And I hope you can work it out yourself. The whole equation B has been multiplied by 3 on both sides. So now that we have got the two equations sorted, we can continue our process of elimination. So what we are going to do now is that we are going to add the two equations. Now, what does it mean to add two equations? You might have added numbers, but you may never have seen how to add two equations. Well, you'll notice the process is not a whole lot different. What you do is basically you line up the two equations. So the equation C and equation D, you just line up on top of each other. You line up in such a way that the same variables appear under each other. So x appears under x and y's appear under y, and the numbers just appear on top of each other. So after that it's easy to add the two of them. Yeah, so we just carry out an addition. So 10x plus 21x becomes 31x, and 15y minus 15y leaves us with 0, and 65 minus 3 gives us 62. So now you can see the variable y has been completely eliminated. We are only left with x in the equation. So we can work it out. So 31 times x equals 62. And we can figure out x because we can divide both sides by 31. So that leaves us with x equals just 2. So these 3 dots mean therefore. So therefore x equals 2. So now that we have figured out x, to solve the simultaneous linear equations, we must also figure out the y. So how do we do that? Well, we have figured out x, we are going to use that. So we are going to substitute the value of x back into one of the equations. So we had two equations, A and equation B, when we started off. So we can substitute it in any one of those two, but we are going to substitute, say, in equation A. So I rewrite the equation A for your convenience here. So it is 2x plus 3y equals 13. So we are going to substitute x equals 2 in this. So that means we're going to replace x with 2. So this becomes, x becomes 2. So we have 2 and 2 in the bracket. It literally means 2 times 2. So 2 times 2 plus 3y as before equals 13. And this becomes 4 plus 3y equals 13. And we have to figure out y. That means we have to isolate y on the left side, which means we have to make y the subject of this equation. Again, if you don't know how to do that, there's a previous video on making how to make a variable a subject. So we shift 4 to the other side. And how do we do that? We subtract both sides. We subtract 4 from both sides. And therefore, we get 3y equals 13 minus 4. And we get 3y equals 9. And now we divide both sides by 3. And we get y equals 3. So we have solved the two simultaneous linear equations because we know what is x and we know what is y. What is the last remaining bit that every smart person should do when solving this simultaneous linear equations? Well, we have to check our answer, right? So how do we do that? Well, let's take the two values, x equals 2 and y equals 3, and substitute into one of the two equations that we had. Okay, ideally in both of them, but let's just try to substitute in one of them. So let's pick equation B. So equation B, again, I'm rewriting it for your convenience. So this was 7x minus 5y equals minus 1. We substitute x equals 2 and y equals 3 in this. So that means 7x becomes 7 times 2. 5y becomes 5 times 3. And the right-hand side remains unchanged. It is minus 1. So we carry out the simplification. So 7 times 2 is 14. 5 times 3 is 15. We have 14 minus 15 equals minus 1. And this makes, this turns into minus 1 equals minus 1. And that's obviously a true result, because in maths, minus 1 equals minus 1. So because we got to a correct mathematical end result, this gives us the confidence that the values that we figured out, x equals 2 and y equals 3, are correct. They represent a correct solution for these two simultaneous linear equations. So I hope that makes sense, and I'll see you guys in the next video.